Alright, we're going to talk about data displays, so different ways to display data. One of those is the stem and leaf plot. So this stem and leaf plot below represents scores earned on a math test in a random sample. From this, you have to find the mean and median. Who knows how to read a stem and leaf plot? Anybody?
No.
Danya.
Is it like?
Alright, you need help?
Yes.
Rasan.
6 got 59.
Joseph.
6 got 5
No.
3 got 5.
No, Danya.
It's like 6 over.
Okay. The stem, so all the ones in this column right here, that's your tens place. So this is 65. And then you have 69. And then you have 73. And then you have 78. And so on and so forth. So go ahead and write down all these numbers. And since you have to find the median as well as the mean, they'd be in order from least to greatest. So go ahead and do this. Alright, we're going to go ahead and start with finding the mean. So we are going to add all the numbers up. So 65 plus 69 plus 73 plus 78 plus 80 plus 82 plus 86 plus 88, 91, and 95. That gives you 807. There are a total of 10. So you're going to divide by 10, and you should get 80.7 as your mean. Yeah, so this is your mean. Now we're going to find the median. So we're going to 1, 1, 2, 2, 3, 3, 4, 4. We have 2 left in the middle. 80 plus 82 gives you 162. You divide that by 2, that gives you 81. Another way to think of this is if you have 80 and then it skips a number and you have the number after that, it's going to be the number in between that. So it's 81. Alright, so the next one we are going to talk about is still stem and leaf. Sorry, I thought we were moving on. Go ahead and do this one on your own by finding the mean and the median. Alright, so all this is telling you right here is pretty much what we just went over. Whatever is on this side is in the tens place, and whatever on this side is in the ones. So if the 1 is on that side, it's going to be right there in the tens place. The 2 is on the other side, it's in the ones place. You have 12. So for this one, we have 0, 2. You can write 0, 2 or just 2. And then you have 1, 2, which is 12. And then you have 1, 2 again, which is 12. 1, 3, which is 13. 1, 5, 15. And 1, 8, 18. And then you have 2, 0, which is 20. 2, 0 again, 20. Then you have 21. 21. 23. 24. And 3 26s. 26, 26, and 26. And then you have 28 and 29. And then you have 2 30s and a 31. So tens place, ones place. So 30, 20, 12, so forth. So now you're going to add all these up together. And you will divide by what? How many numbers do we have? We have 20 numbers. So 2 plus 12 plus 12 plus 13 plus 15 plus 18 plus 20 plus 20 plus 21 plus 21 plus 23 plus 4. Remember, if you were doing this in your calculator, add up all the numbers together and hit enter before you divide. Because if you don't, it goes by PEMDAS in the calculator. So it'll divide before it adds them all together. So add them all together, hit enter, and then divide by 20. So what is our mean? 21.35. Now what about our median? What's the median? 22. So we're going to go 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, and we have these two in the middle. 21 plus 23 is 44, divide by 2 is 22, or just the number that's going to be in the middle of those, which we know the number that comes in between 21 and 23 is 22. Any questions so far? All right, so the next one is the dot plot. So the dot plot below represents a random sample of students who were asked how many siblings they have.
Is Jamari Collins in there?
All right, the dot plot below represents a random sample of students who were asked how many siblings they have. Find the mean and median. How do we read the dot plot? Danye.
For the second dot, like for the first 5, you go like that's 1, then that's 2, then on the 1, you go that's 11, that's 12.
No. Jaden. Yes. So for this one, 2 people answered 0, so that's 0 and 0. 3 people answered 1, so it's 1, 1, 1. 1, 2, 3, 4, 5 answered for 2, so that's 5 2s. And then 3 3s and 2 4s. Now look at the surveys we did around the room. What were those? Dot plots. So now take this and find the mean and the median. These up, and we divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What will we get? 2.
Yes.
So the mean
It's 2.
is 2. I think one of the common mistakes is you don't include the zeros. So therefore you add all these up and you divide by 13. But you have to include the zeros. That is part of your data. Just like when you get a 0 on an assignment in class, we don't just make that 0 disappear. It still gets put into your average, right? All right, what is the median? So we have to just keep going back and forth, back and forth, back and forth. And you will eventually end up. It should be just 1, 2.
Yeah, I got it right.
2. So the mean and the median is 2. One thing one of the students in other classes noticed was that when you have this, it's called a bell curve.
Oh, yeah, I know that.
So when there's the same 2, 2, 3, 3, and you have 5 right here, your mean and the median will always be the same when it's a bell curve. So, just a little tidbit about that. Now, you are going to find the mean and the median for grade 6 and grade 7, and then you're going to find the difference between them. If we are finding the difference, what are we going to do? So on your own, do this. All right, so if we add all of these numbers up, so we have 6 70s, 4 80s, 6 90s, and 4 100s, we would get 1,680. And then we would divide by 20, and we get 84. Now we're going to get our median. But let me show you a way to do it. You're doing it on paper, and so you don't have to write it out. So you start with your smaller number, and this is your largest. And you go back and forth, until you end up with your middle numbers.
Oh my. You're brilliant.
All right, so we end up with 190 and 180. So 80 plus 90 170. And if you divide that by 2,
85.
that's 85. So this is our median, and this is our mean. Now we need to find the median and mean for grade 7. Alright, so for this one, we have 1, 2, 3, 4, 5 50s, 7 60s, 4 70s, 4 80s. We add those all together and divide by 20, and what do we have, Kevon?
60.8.
63.5. And then we're going to start trying to find our median. 3, 3, 4, 4, 5, 5, 6, 7,
60.
the median will be 60. We'd have 2 60s added together, divided by 2, that gives us 60. Everybody get this?
Yeah.
Now it wants to know the difference. So the difference for the mean, you're going to take 85 and subtract 63.5, and what do you get? 20.5. So the difference for the median, you're going to take 85 and and subtract 60, and you're going to get 25. That is our answer. Alright, so now we are going to move on to circle graphs, and we're going to talk about prediction error. So go ahead and we're going to look at this. You took a random sample of 27 7th grade students to determine the most common eye color. Your results are represented in the circle graph below. You should have seen circle graphs already. So this color represents 10 brown eyes. This color represents 10 blue eyes. This is for Hazel. This is 3. That represents other. So we're going to find the sample proportion for each eye color. You should write this down. Sample proportion is equal to part divided by whole. You remember when we did proportions a few months ago? Part over whole? It's the same thing. Part divided by whole. So we're going to have to find the sample proportion for brown eyes, blue, Hazel, and other. Yeah, so all these added together, how many do we have? 27. That is our whole. So each one is going to be divided by 27. So we know that brown is 10. So 10 divided by 27?
2.7 twice.
No, 10 divided by 27. Most of you are dividing 27 by 10 and get 2.7. Part is 10 and divide that.
That's 0.3.
So we have 0.370 so forth. So we're going to round to 0.37. Blue eyes is also 10. So we know from the one vote for it that it's 0.37. Hazel eyes is 4. 4 divided by 27 is 14, or it's 0.148. So we are going to round up to 0.15. And then other is 3. 3 divided by 27 is 0.11. So we're just going to round to the nearest hundredth. That is how you find your sample proportion, your part divided by your whole. So now here's another one we're going to look at. A population consists of 600 girls and 400 boys. Jose wanted to investigate what he could expect to happen if he were to take a random sample of 20 people from this population and calculate the proportion of girls in the sample. So he chose 20 students, so that's our whole. Because what is the proportion of Jose's sample, right? 20 is our whole, so we're going to have to divide something about 20. So B represents boy and G represents girl. So let's count our G's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 divided by 20 is what? 10 divided by 20.
2.
No, 10 divided by 20. 0.5. Remember, don't do 20 divided by 10 and get 2. It's 10 divided by 20 is 0.5. Now, we're going to do prediction error. Alright, so if Jose selected 20 students at random and recorded the following data, what is the proportion of girls in Jose's sample? We know the whole is 20, so however many girls is going to be divided by 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divided by 20 gives you 0.5. That is the proportion of girls in Jose's sample. So from this, we're going to use the whole sample to determine our prediction error. Not the whole sample, the whole population. So prediction error is the difference between the sample proportion and the actual population proportion. So we know that the sample proportion was 0.5. We know that a population consists of 600 girls and 400 boys. So we're trying to find girls, so 600 girls divided by the whole. 600 plus 400 is 1,000. That gives us 0.6 when we divide. So now we need to find the difference in order to find the prediction error. So 0.6 minus 0.5 gives you 0.1. So our prediction error is 1/10.